Hello everyone and welcome to today's webinar. Today I'm going to talk about our new Silver tool in version 4 and exSILentia's data core and how they work together. First, a few notes about the webinar application. Audio is provided via the application over the internet. So please enable your speaker in all places. The application has muted your microphone, so I cannot hear you. However, there is a questions tool at the right side of your screen. You can use this at any time to ask me questions, and I will answer them during the webinar. I can also answer them over email if you prefer. My name is Kate Hildenbrandt. I am a product manager at exida. I'm responsible for strategy, roadmap, and feature definition for exSILentia software. I also focus on providing training and software support to new and existing exSILentia customers. So for that reason, I have my email address right here. Please feel free to use it. Ask me any questions you have. That's khildenbrandt@exida.com. A little background on exida. We have three main offerings. They are our enterprise tools, which we're focusing on today. We also do lifecycle services and certification. We believe that all three of these will help you get a full picture of your safety situation. We also have offices internationally, so hopefully on this map you can see our different locations, and hopefully you have an exida expert near you. I myself am located in Sellersville, Pennsylvania, right outside of Philadelphia. So let's dive in. We did have a major update to our exSILentia tool at the end of 2017. And the biggest part of this update is that we have Silver now on the V4 platform. We also released the proof test generator and file converter that will take your V3 project Silver to V4. And one of the biggest changes between the versions is that Silver now extensively uses what we call the data core and the data stack, which is one of the integral parts of this version 4 platform. So you might not know what that means. We're going to take a deep dive into that. So for those of you familiar with exSILentia, you know it works to streamline the process safety management work process by using a number of separate tools on the same platform. Obviously today we're focusing on Silver, but you might be familiar also with our PHA tool, our LOPA tool. We have a SIL selection tool, 2 SRS tools, a SIL alarm tool for alarm management, and SILstat, which is meant to track the performance of your plant while it's up and running. So all of these tools can basically be used on their own, and they're best in class, great tools on their own. But the best way to use them essentially is to use them together. And so what you see here, and what we're trying to emphasize, is that data can flow from one tool to the other to basically optimize your work process when you're analyzing your system for potential risk. And so again, you can do this in separate tools. You could do your PHA, and in your PHA you would analyze the inherent risk in your system, and you might define safeguards against that risk. Then in your LOPA, those safeguards become independent protection layers. Now, if you're using two different tools, you might have to stop and either import or re-enter that safeguard information into a new tool. The same goes for SIL selection. Perhaps you've done your layer of protection analysis and you want to determine your target SIL level. Is that done in the same tool or a different tool? Finally, you might have to start from scratch when you're writing your safety requirement specification. And all of this is obviously done before you can design your safety instrumented system. The way exSILentia works is that it just automatically transfers that information from one module to the next. So your safeguard automatically becomes your independent protection layer, automatically becomes your SIF, if that's what it is, and you can do SIL selection, safety requirement specification, and SIL verification on that same item in the tool. And the way that works is because we have what we call a data core. The main part of the data core that would help with this data transfer is what we call libraries. And the libraries in exSILentia capture user input information. And so any cause, consequence, hazard scenario, initiating event, anything you're entering into the tool basically gets an item number and is stored in the library. In the case of the safeguards, because we know that eventually might become your SIF if that's the kind of safeguard that it is, all of the information throughout the life cycle is stored under that library item. So if you're finished with your project and you want to come back and see all of the analysis and design information, you can simply go to the library for that. It also allows you to link and reuse items throughout your system throughout the life cycle. And so that's very cool. Another part of the data core that we like to highlight is our databases. So if you're familiar with exSILentia in version 3, you know that we have what we call our Safety Equipment Reliability Handbook. And this is where we provide to you failure rates for devices used across the industry. So that would be any part of the SIF, your sensor, logic solver, final element, and any interfaces that go along with them. The database also provides proof test coverages and proof test procedures. So if you're choosing from that list, you can then use the proof test generator to basically determine your proof test procedures. And then the third part of the data core that we want to focus on is project and risk configuration. And this part is basically capturing and institutionalizing your corporate knowledge. So you can set up your risk configuration you always use throughout your corporation. If perhaps you are doing different projects with different configurations, you are able to save your configuration and then import it in. It's fully customizable so that you're basically using a consistent starting point for anybody who's working on the project throughout the safety lifecycle. And so that is something that I think is new to exSILentia and that is easy to use, and now it applies to Silver as well. And so those three things, the library, the databases, and the project and risk configuration are what we refer to as our data core. And it helps transfer the data all the way through the life cycle, as you can see here. Now for Silver, this is used in very specific ways, which is what we're going to get into later on in the presentation. First, I want to mention the data stack. So what I showed you was the project level. Again, you can use the tools separately, or you can use them together on sort of a project data flow basis, and that would be your project level. But we don't want the data to really stagnate there either. And so we've made it possible for exSILentia to move that data to do other important things for your project. So one, we can create a master alarm database out of exSILentia. We can also configure your PLC, your safety PLC, using your inputs into Silver. And finally, we can interface with a CMMS or ERP system. So again, the idea here is that the data you're inputting, the work you're doing, is never going to sit and stagnate. You can always move it. You can always leverage that for your next task. So let's go over how Silver uses this data core. And the first thing we're going to look at is, again, the library. So the library captures all of your user input information. And this is essentially what makes the data transfer between tools possible. For Silver specifically, it allows for advanced reuse of sensors, final elements, and logic solvers. It's also keeping track of your project-specific information, like what kind of device models are you using, and what are your specific devices. Now, that might sound a little confusing. I'm going to explain it in a minute. First off is the data transfer between tools. So all information for your safeguard, which later becomes your IPL, which later becomes your SIF, is stored in the library under an ID number. So you see a screenshot here, and it has a 1. It says 1 pressure interlock, and that is the safeguard ID. So the tool is essentially tracing this entity throughout the life cycle and storing all the information associated with it here in the library. So here you see on the left-hand side of the screenshot, you have your analysis information. So it starts with the safeguard name and description, your safeguard tag, any consequence information or references that you use for analysis. A little farther down, we have some of the SRS information, your process safety time, maximum response time, and then your intended mission time, startup time, and demand mode. And the reason we say intended is because at this point in the life cycle, you are creating your design criteria before doing the design. So it's not the implemented, it's intended. A little farther down, you can see your IPL information, which comes from the LOPA, and finally the resulting required SIL and required RRF for this. And at this point, it's determined to be a SIF. So all of that on the left-hand side is your analysis information. Then on the right-hand side, you can see your design information. So this is essentially what you're focused on for SIL verification. You have your SIF name, your SIF description, a tag. You can specify an analyst and an analysis state, and you can again link any design references. Further down, you have the parameters that will be affecting your calculation, your SIL verification calculation. So you have the basis for your architectural constraints, whether or not you're considering SIL capability. You have your as designed mission time, startup time, and demand mode. So intended versus as designed, and they're lined up so you can see if anything has changed from what you wanted to design versus what was actually determined in your conceptual design. Version 4 Silver allows you to specify if you want your input-output channels on separate modules for the SIF. So that's that checkbox there. Then you have your site safety index information, and finally your achieved SIL and achieved RRF. So all of this information is in the library. It's not, what you're looking at here is not all in the Silver module, but in the library you can take a look at your analysis versus design information. This is what makes it easy for you to use this entity throughout the life cycle. So again, you start with your PHA LOPA. If you're doing PHA in a different tool, then you start with your LOPA and the rest of it is blank. But what's really nice here is you can always go in and look at all the information you need for safety right in the same spot. And so this makes it easy for data transfer from SRS to Silver, and then obviously from Silver to SILstat. If you want to keep track of your safety instrumented system as the plan is running, collect data, make sure you're up to date on your proof tests, all of this information is pretty important. And so the library allows you to do that in version 4. It also allows for advanced reuse of sensors and final elements. Now, we call it advanced. If you remember in version 3, when you wanted to reuse an item, you basically just clicked a checkbox and you knew that it was working to reuse the item. This is a little bit more organized in that you can go to the library and you can define your items right away, or if you want to do it in the module, the library still captures those items. But you can go in here and look at all of the information for your sensors or final elements and see where they're used and keep track of them that way as well. And so we call it advanced reuse because you're essentially linking from the library and it links to that same information. The tool is keeping track of it. Any modifications made later on are going to modify everywhere. And so it really drives consistency throughout your analysis and design. In this case, it's driving consistency. If you're changing your sensor, you've changed it in all places. And so this is a really neat, organized way to do it versus the way it's done in version 3. We can do the same with our logic solvers. In this case, the logic solver is more intelligent. Silver is essentially keeping track of the input-output channel allocation, and it thereby essentially knowing how your cabinet would be wired. So it takes reuse of sensor and final element groups into consideration. And obviously, in this case, your logic solvers can be reused throughout the SIS too. So if you're reusing your logic solver for a lot of different SIFs, the tool knows exactly how many inputs and outputs it has, etc. And you can see this on the screenshot over here. It might be a little bit small, so when I open up the tool, I'll show it to you again. But here your logic solver is specified, and you can see all the modules. There's a module for the main processor, the power supply, and then you have your input-output modules. And you can see the sensors and final elements that are attributed to those modules, which is very cool. And so it's an intelligent logic solver design. This is totally new from version 3 and definitely more accurate. So that is one cool thing to add. Now, the tool is keeping track of your project information as well. Well, what does that mean? Well, essentially, you have a lot of specific devices you might use repeatedly throughout your safety instrumented system. And so the library keeps track of your device models. So what that means is, for example, if you have 50 pressure transmitters of the same make and model in your process, Silver will define one device model for that transmitter, and then it's also keeping track of the 50 separate devices. And so this allows you to essentially, it allows you to basically have favorites where you're selecting the models you've used from a drop-down as you're going through. You don't always have to select directly from the SCRH because it knows what you're using. It also allows you to keep track of the physical devices. So eventually those 50 separate devices have to go into maybe SILstat or something similar so that you can track the performance of your plan. So you'd give all of them serial numbers at some point, and you'd keep track of what's being changed out, what's being repaired or replaced in case of a failure. So this allows for really easy tracking of your bill of materials, your failure rates, your device performance, both for a singular device, but also for those device models. If you find that that pressure transmitter that you put all throughout your plant is actually kind of a problem child, this is a good way of keeping track of that and determining that for yourself. So that is another thing that the library does that version 3 did not do. So that sort of closes out how Silver specifically uses the library. We do have some project configuration or knowledge capture as it applies to Silver now. So in the project parameters, you can specify basically defaults for your SIL verification that will be applied to all the SIFs, and then in the module you can change them as needed. We also have a number of predefined reports that go along with the Silver module. So here you can see our project configuration, and what we're showing in the screenshot is the Silver project parameters. And this looks a little familiar. You saw something similar in the library, and what it is basically at the top of your project you can set some basis, some defaults that can be applied to your safety instrumented system. So every time you create a new SIF, you're going to see these parameters as your default, and then you can overwrite them. So for instance, if you know what your basis is for architectural constraints and it's consistent for all SIFs, you can specify it here once, and then it'll be done for the rest of the safety instrumented system. You can say here if you want to consider systematic capability, exSILentia defaults your mission time to 15 years, but if you know it's 20, you don't want to have to change that every single time you create a new SIF, and so you can do it here and it will automatically show up. So you get the idea. We have certain things for sensor groups, for proof testing. If you know that your proof test interval is always 1 year, you can put that in here. we have certain things for your logic solver and your final elements. And so all of this sort of can be used to capture corporate knowledge, even guidance maybe. You can set it as your default, and then every time you open the project, things are set to the parameters you want. Obviously, they can be overwritten in the module when you're working on a specific SIF. And I just want to point out one more time that a new option for version 4 is being able to specify I/O channels on separate modules for a SIF. And so that can be done in here as well if you know that you want that to be done for your entire safety instrumented system. We have predefined reports. So we have a Silver summary report if you just want a quick overview of your safety instrumented system. We then have a detailed report, which provides all the details you would need to redo the SIL verification at a later date. So that one's pretty extensive. We have a SIF list, which is a pretty quick overview of each of the SIFs. And then we have the proof test generator. So for any piece of equipment that you choose out of the SCRH, we have an associated proof test coverage, and then that proof test coverage comes with a specific procedure. So all of that can be generated into a report where you can basically have your proof test for your entire safety instrumented system in one report. And if you have SILstat, you can also import that into SILstat, so you can essentially take a tablet out into the plant and record your proof test right into the tool. And so that's pretty cool. Finally, we have our database. So for those of you who have been using exSILentia for a while, you're very familiar with our Safety Equipment Reliability Handbook. Obviously, this is still in version 4. It's got a bit of a new look. As you can see in the screenshot here, we have a new viewer. You can go in here and you can choose your piece of equipment and see the data sheet that you would see if you had bought the hard copy. And this again is providing your failure rate data, your proof test data, useful life data, etc. It's important to note that when you go through here, we took a screenshot of the generic so you can't see it, but your certified devices will be in bold. And so any device that's certified in the SCRH will be easy to spot and put into your design. But we have both certified and non-certified devices. We have 1,500 unique equipment items in the SCRH. So that is our way of putting the data you need at your fingertips. We also, with the library, have the capability to allow you to make a project level device model database. So again, we touched on this a little bit earlier, but every single model you're using in your, every single device model you're using in your design is saved into the device model category here. Likewise, if you're putting in your own devices, you are able to put in user-defined devices, and that is also stored there. So if you're familiar with version 3, you know that if you want to put in your own device, you sort of have to enter the data in every single time you use it for each different SIF. Those days are over. In this case, you can put in a user-defined item straight into the library, or it will capture it if you want to do it while you're modeling. But once it's in there, you don't have to define it again. You can simply link it from the library every time you're using that device model. So this makes for very easy reuse of user-defined items, but it also basically creates a database for you of your user-defined equipment, which is very cool. So that sums up the data core and how Silver uses it. Obviously, we're excited it's a brand new tool, but being able to leverage some of the things that were already a part of exSILentia's version 4 platform has made it even greater functionality for you to use in Silver. So I am going to open up the tool and show you some of these things directly. Okay, so we do have a few questions. Someone asks how your SIL verification calculation is affected by process safety time and max response time. So that is a good question, and I would want to verify my answer with someone and get back to you. I believe they're in there in the analysis section for the SRS, because that is a requirement in the standard that you have to document that in the SRS. I'm not exactly sure if it impacts the calculation, so that's something I can get back to you on. So let's open the tool. Okay. So hopefully you can see the tool now. A few things I want to point out before jumping right into the silver module. This is the dashboard. Here you can see the different modules and how they're lined up. So you have PHA, LOPA, Select, SRS, and Silver at this point. A lot of the data core features are accessible right here. So the first one, we have the library, and I'm going to show you a few things about it as we go through. But just so you're familiar with it, earlier I showed you the safeguard information, and that's here. So each safeguard has an ID, it has a tag, it has all sorts of information. And if you want to view the analysis and design information side by side, you can do that right here, as I showed you earlier. And so this is a good way to basically not only have all of your information in one place, but sort of compare, is your intended mission time matching your design mission time, startup time, demand mode, etc. Is your required SIL and RRF achieved? That kind of thing. And so it's very cool, but as you go through the life cycle, this is built upon, and you can reference it here at any time. The library also includes things like references. So here we just have the standards, but if you are, I have a few notes here that you can't see the demo. I wonder why. Let me check. Let's do this way. Okay. Thanks for letting me know, everyone. So here's the safeguards. Let me go back and show you. You can go into the safeguards in the library, and you can view your analysis and design information. Like I said, pointing out some of the intended or required information in the analysis that you know you want to put into the design versus the as designed information and your achieved results. So you can compare and contrast here, but it's also a nice place to go to see everything at once. There are other things here like references. So here we have the standards here, but you can input anything, PNIDs, any documents that pertain to anything throughout the life cycle. And you can put details on the reference. You can also link it here from like a SharePoint, or you can attach it directly to the tool. At different points in the modules, you can link the references, and that's why here you can show places used for the references. So that'll show you where that document is linked throughout the life cycle. If you keep going down specific to silver, we have our sensor groups captured here, sensor legs. We have logic solver models, so just like device models. If you're using only one kind of logic solver, you're going to see it here in the models. If you're using a couple different kinds, they'll show up. And then you have the specific physical logic solvers you've used. So if you've used 2 generic SIL3 certified PLCs, they would both show up here. Device models work the same way. Any device model that you use will show up here, including your user-defined device models. And then some of these are obviously used multiple times throughout your safety instrumented system. And so each instance of that device model is shown in the devices. And again, at some point, you might give these serial numbers and track them in a program like SILstat. Final element groups and legs are kept track of, as well as tags. So all of your logic tags can be put into Silver, and eventually you'll be able to configure your safety logic using these tags. So that gives you an overview of the library. Let's minimize. Another cool thing right here on the dashboard, which I guess you hadn't seen before. Again, here are the different tabs. So you have your PHA, LOPA, SIL selection, SRS, and Silver. Right here you see the databases. For Silver, obviously, you're most interested in the SCRH. So you can click on this, and here is the entire SCRH. The viewer allows you to click on the device, and you should be able to see the page that would be in the textbook for that device. And so here for this device, you can see the failure rates and the useful life and all of that. And so you can access it here on the dashboard. You can also access it from the module, obviously, as you are specifying your equipment. And then finally, we have the project configuration. You can go in here and you can go to your Silver project parameters and define some defaults for your design. So here you can decide, for my entire safety instrumented system, I want to consider IEC 61508 tables for my architectural constraint basis. And so I walked you through this in the slides, but this is where it is. Again, this will make these defaults for your SIL verification, but they can be overwritten as you're going through and modeling each SIF if needed. So if we go into Silver, I have 2 SIFs here already modeled, and the way you work through Silver now is with a navigation tree. So if I want to take a look at this SIF, I just click it here. You want to see the individual parts. You can expand it using that triangle. You have your sensor part, your logic solver part, and your final element part. Each part can, you can model sensor groups, and then within the groups you would define sensor legs, which is where you would specify your equipment. So I've clicked on the sensor part. You can see here I have a group, and you can also see the legs here. And then you can go through and do each that way. I'm actually going to model a new SIF so that you can see how I would go through it. So as you see here, we have this new SIF. We can name it anything we want. So we'll say high pressure SIF, and I can call it SIF 003. I can link an analyst from the team members defined in the project configuration, and I can link a reference. So we're going to say 61508 and link that. Here I can change my basis for architectural constraints if needed. I can decide if I'm going to consider SIL capability with this checkbox. In this case, we always want to emphasize that you either need to choose a certified device or you need to do a proven and use justification. We assume you're going to do that either way. So by unchecking this button, we're assuming that you're documenting that elsewhere, not that you're completely disregarding the systematic capability, but that you just don't want to do it in the tool. You're going to specify your as designed mission time here, your as designed startup time, and your demand mode. The same with version 3, you can base your demand mode on demand rate and have the tool calculate it. As I said a couple times, you can determine if you want your input-output channels on separate modules in your logic solver for this SIF. And then we have our site safety index. In version 3, this was called the maintenance capability index. And it's basically a measure of how well you're keeping up with your repairs and proof tests and things like that at your site. We always default to good repair, which is essentially average. Once I'm done modeling my SIF and I have results, the achieved SIL and RRF will show up right here. So then I want to get started. The first thing I do is I navigate to my sensor part and I add a group. I'm going to do a pretty simple SIF here. As soon as I add a group, I have to do my voting options for my leg. In this case, it defaults to 1 out of 1, and I'll keep it there. And so it's showing me caution because I don't have any legs. So I click this button to add a leg to match the vote. If I am doing 1 out of 2, it can automatically adjust for me. And then if I'm doing diverse legs, I can press this button and you'll see both legs. If I'm not doing diverse legs, then you only have to specify it once. In this case, you can specify a beta factor here, and we do have a beta estimator if you want to go through a questionnaire to make sure that if you think 10% is too high, you can go through this beta estimator. Here you'd specify your mean repair time. Next we have proof testing, so you can specify your interval. You can specify your coverage. If you're going to use an item out of the SCRH, you can wait and then use the proof test coverage calculator afterwards. You can specify if your test is performed online, is it staggered, is there alternative protection while it's performed, and what is the duration of your test if it's performed online. From there, you can come in here and specify your sensor. So I'm giving it a name. I'll say pressure transmitter on inlet to reactor. The first thing you want to do is select the measurement type. And you'll notice before you select that, you're not going to be able to specify any devices. So measurement type, in this case, it's pressure. We can specify the trip setting as high, low, or none. We're going to keep it on high. And if the transmitter has an internal fault, which way does it drive the signal, under range or over range? We'll stick with under range. Now that I've specified the measurement type, I can select my equipment. If I press this big button, you're going to see the SCRH. At this point, this is fully, you can filter your results as you search for the device you want to select. So I'm just going to, for the process connection, say that this is clean service, I don't expect any plugging, and I can add that. Then I'm going to pick my sensor. So I have to take off that filter, and I want to put in a generic pressure transmitter. And we'll put that there. Now that I've chosen an analog device, it's giving me PLC detection configuration options. So if the signal is out of range, can my PLC detect it? Yes. In that case, is there a fault filter, or will it trip on transmitter fault? So you can select from those. So that's pretty straightforward. Now that I've selected these from the SCRH, I can go to the proof test coverage calculator and get the proof test coverage from the SCRH. And so you see how the tool essentially works. Here, when I try and specify my logic solver, I can choose from the drop-down list and just choose the same logic solver from earlier. Or I can go to the SCRH and choose a new one. I'm going to choose this one. And so here you can see I can specify proof test interval. I can specify proof test coverage, but you're already seeing how it is already assigning your signals to the logic solver. So here I haven't named this identical sensor leg, but we can name it PT203. And in the logic solver, you see that because I asked for these input-output channels to be on separate modules, one of them is on module 3 and one of them is on module 4. So that's already doing that work for us. Then I can go to the final element. I'm going to add a group. I'm going to make this just a simple final element, XV303. And we'll say this is a valve on reactor outlet. You have like options, so you can say valve open on trip, is tight shutoff required, or is this valve going to be in severe service? If you select tight shutoff or severe service, the tool will use a different set of failure rates as defined in the SCRH if applicable. And so that's what those are for. We're going to leave it close on trip. I'm going to specify a generic three-way solenoid, and I'll specify a generic ball valve. And there you go. So that is specified. We want to do the proof test coverage calculator, and my SIFs should be fully modeled. Now here, now that I've done the final element, you can see that that has been added to the logic solver here. I'm going to calculate the SIF, and you can see my results. Now my results aren't very good. My achieved SIL is 0 because I selected all generic equipment. It's not certified, so I'd have to go in and do a proven and use justification for whatever I'm using. But you can see how the tool works. Here we have the required SIL and RRF. If I had specified that earlier, you would have seen either from SIL selection, or I could go in the library and do that, but that would show up here. Now you're seeing my results, achieved SIL and RRF. The tool also shows you the risk reduction factor, PFD average, and mean time to fill spurious for the different parts of the SIF. So you can see it for the sensor, the logic solver, and the final element, and then again for the total SIF. You see your achieved SIL according to PFD average, according to architectural constraints, and then according to systematic capability. We show you here the response time. And we have the same graphs we had in version 3, where it shows the contribution of each SIF part to the PFD average and to the mean time to fill spurious. So if I wanted to come back in here and get higher than SIL 0, which I'm sure I do, I know I need to focus on the final element. Finally, we have PFD charts where you can see your probability of failure on demand over time for the full mission time, and then the PFD average. So you can see this for the entire SIF, and you can see it for the different parts. So here's your sensor, or your logic solver, your final element. So you can take a look at that. Almost close to project. So that is in a nutshell how you would model a SIF in the new Silver. Again, you can go back to the library and check out some of the information that we input. I think I used a lot of the same devices that you saw earlier in the library. A couple things, I could go in here if I wanted to, and instead of instead of using something from the SCRH, I could do a user-defined device, and this will essentially open a new library item and allow you to fill out your information for a user-defined device. It would then work just the same as the SCRH, where you can reuse this item as much as you want. You don't have to define it multiple times. You can also use this link button to, from the library, choose a device. And so again, since it stores all of your information from your project, you can simply link those things. And so that is Silver in a nutshell. I do have some questions here. It says, how is the SIL verification calculation affected by selecting different I/O modules? One thing that the new Silver does that the old Silver did not is it puts those different input-output failure rates into the sensor part and the final element part of the SIF. And so it's calculating it a little bit more different and a little more accurately than we did in version 3. So that's very cool. So yes, it is going to affect your calculation a little bit. And I want to point out that we are going to have another webinar next week on basically how to upgrade from version 3 to version 4 and how opening your version 3 file in version 4 is going to affect your project. There's some new functionality that will affect it, and obviously the calculation will be slightly different because of the I/O channel application allocation. And so that'll be something that we talk about next week. All right, so I think that's it. I think there were a few more notes. If you can hopefully now see my presentation in a minute. Okay. So oh, someone has a good question. What about a partial valve stroke test? So let me open my tool again. So I didn't go over a partial valve stroke test. If you go into the final element, you can do that here. You can simply click enabled and define your interval. So let's say we do this every 3 months. Define your duration and your coverage. One cool thing that you can do here, here you're going to specify, it says automatic, and what this means is it initiated automatically? So a lot of people ask us, oh, well, it's done automatically, but I have to push a button for it to go. No, this means is it initiated automatically. You can use equipment data for the coverage, and it's going to tell you if the PVST mode is static or dynamic. One cool thing that we can do here that we couldn't do in version 3 is you can basically specify if the partial valve stroke test is attributed to all of the devices or not. So say mine doesn't affect the solenoid, I can unselect that, and that is not going to be counted in the calculation. And so that's something we couldn't do in version 3. So that's where you would do that. Okay. So just one thing I want to point out again, like I said, the webinar next week is going to deal with Silver as well. And what we're going to be talking about is how you can upgrade from version 3 to version 4. And how opening a version 3 file in version 4 will affect your existing project files. So we'll take a deep dive into that. We also have a SIL verification with Silver course scheduled for April 10th and 11th in Houston. So that is up and coming, and it's open enrollment, so all are invited. You can sign up for a free trial of the tool on exSILentia.com. This is a 2-week free trial, and it does have V4 Silver on it. You can always follow us on Twitter for latest news. And if you have any questions, please contact me at khildenbrent@exida.com. All right, so that's it for today. We will be sending out a recording and a copy of the slides, and you can reach me with any questions you have. Thank you so much for attending.